Welcome to AP Calculus Lesson 4-3, Tangent Line Approximations. My tablet is not working because it's not plugged in, but today's date is November 4th, 2020. As soon as I plug this in, it's probably going to mess up the projector. Ready? And, no, okay. Let's write down 11/4/2020, the day after the elections. All right, the objective today is to do what? I'll give it a Teflon.
Solve problems with lines that are tangent to functions.
There it is. Yeah, and man, I can't tell you how often these problems come up over and over again in different forms. So definitely a lot of points in the AP test here. Let's do example number 1. And there are these same 4 steps over and over and over and over again. You'll always have these 4 segments, and there'll be slight differentiations in between them. So in example 1, we have this line 4x plus 2y is equal to 4, and that is our tangent line. It tells us, hey, your tangent line looks like that. And we don't know what the curve is. The curve is some function that looks like y equals 2x squared plus k, but what is the value of k? And you could solve this with Desmos. Like I could go do it right now. Actually, let's do it to check our work, right? And then we can compare our sketch to Desmos and see how well we did. But with Desmos, I think this takes like maybe 30 seconds. With calculus and doing it without any graphing software, it takes a little bit more time. So I told us that our tangent line is this 4x plus 2y is equal to 4. I know that the curve is y equals 2x squared plus k, and the goal, find k. So what do? Well, we want to eventually take the derivative of both of these. But before I do that, I kind of want to get y isolated because I don't want to have to worry about moving things around later. So let's go ahead and isolate y, then we'll take the derivative of both the right piece and the left piece, the curve and the tangent line. So rearrange, let's subtract 4x and divide by 2. So I'm going to do that in 2 different steps. So I get 2y is equal to negative 4x plus 4. Divide everything by 2, and I get y is equal to negative 2x plus 2. So far, so good. That's just, I don't know, first month of Algebra 1 work. Now the AP Calculus work, take the derivative. Fiona, go for it. Yeah, so y prime in this case, right? Because we're taking the derivative. Yeah, so y prime is equal to negative 2. Cool, done. And remember, what are we finding here? This is now what we've written in here in red. This is the slope of the tangent line. So just to make sure you understand the grand scheme of things, we just found the slope of the tangent line. We are given the equation. We now know the slope of the tangent line. Okay. Well, let's go ahead and find the slope of the curve also at that point, because those 2 slopes should be the same. That is the definition of a tangent line. If I have some sort of tangent line that is tangent to the curve at that point, if I look at that curve at that point and take the derivative, that slope and the other slope should be the same slope. We can set them equal to one another. The way, when we do this, we should somehow get the x coordinate out of what is the x coordinate where these 2, where the tangent line meets that curve. So again, take the derivative, Andrea. The curve is going to be this, y prime is going to be 4x. Okay, there it is. So these 2 slopes have to be equal to each other because it happens at the same point. So we can set these equal to each other now. So I can say, okay, well, I can use some color coding here. So this y prime is equal to negative 2 is going to be substituted in for this y prime. And I get negative 2 is equal to that 4x. And then I solve. Teflon, x is therefore equal to
2.
Careful, divide both sides by 4.
Negative 1/2.
Negative 1/2, there it is. Okay, which is not what we're trying to find. We're trying to find k. So how does that help us? Well, we can keep plugging that back into the tangent line now. We know that the tangent line has this equation. If we plug in an x into it, we'll get out the other unknown variable, a y, which means we'll know the x and y point. Once we know the x and y point that the tangent line and curve both have, I can plug in that same x and y, and then I'll be able to solve k. That's the grand scheme of things. So let's go back through that. Let's plug it back into our tangent line. Can we rewrite our tangent line? But in the place of this x, we know that that x is -1/2. So write out our line. This is going to be 4. There's our x. I'm going to leave open. Plus 2y is equal to 4. We know that they're -1/2. I'm going to just change the color randomly right here. This -1/2 is our x that got plugged in right here. That is -1/2. And I guess we could have just plugged into this equation over here instead of our original equation, y equals -2x plus 2. That might have made our lives kind of easier, but whatever, we'll work with this. So from here, we have -2 plus 2y is equal to 4. Yeah, Fiona, do you want to just solve the rest of this for us? What is y equal to? Y is equal to 3, yeah, because you'll add 2 to both sides, you get 6. 6 divided by 2 is 3. So y is equal to 3. All right, which is helpful information because now we can plug in both our x and our y into our curve equation. When we have the x and the y plugged in, the only unknown variable that we have is k, and we're done. We were trying to solve for k. That was the original goal. So we come back to our curve equation. Again, we're going to rewrite everything that we see in the curve equation, but in the place of y and x, we are substituting our x out for a -1/2. We're substituting our y out for a 3. So let me write out our empty space for y is equal to 2 empty space for the x, quantity squared, plus k. Our y here is 3. Again, drawing an arrow here to let you know where those numbers came from. This x is the same x that we're going to be plugging in over here. So that's our -1/2. And then we solve. Andrea, take us away. Three is equal to what? 2 times 1/2 to the -1/2 to the power of 2 is 1/4. Perfect. Plus k. Keep going. Perfect. Yep, -1/2, and you get yeah, 5/2. 5/2, or you can also say 2.5. Either way works. And we box it. Done. All right, so I think I'm actually going to show the graph first, and then I'll do the sketch of the graph in a second. So what really happened here? Let's go back to the original equations. I'm literally going to type these two equations in black right here that were given to us into Desmos. And I'm not using the scientific, I'm using the actual calculator, the graphing calculator. And the difference between the URLs is calculator is the graphing calculator, scientific is just the calculator. So again, our equations were 4x plus 2y is equal to 4. So that's a tangent line, and then y equals 2x squared, plus k, and it's like, oh, what's k? And I'll make it a slider. So it's asking, and let me make this projector mode so you can actually see what's going on here. It's asking, if I drag this value of k around, when do I have this line actually tangent? And the answer is, oh, if I keep dragging it up and up and up and up, and right there, oh, right there. Now it's actually tangent. If I come over here and click, that intersection is -0.53. And hey, look at that. -0.5 is the x coordinate. X coordinate is -0.5. Our y coordinate is 3. Our y coordinate is 3. So we know the x and y coordinate of that point. And then we can also say, okay, well, that means our value of k had to be 2.5. Everything here matches with what our problem was showing us earlier. And this is probably the reason that the AP test doesn't want to use the Desmos calculator, because there's no calculus that is involved in typing in your equations and dragging around a slider. But you can solve this with calculus. So let's go ahead and make a graph, a sketch of that graph right here. So we had our k value is 2.5, so everyone can graph the point 2.5. That should be the vertex of our parabola. And we also had the point that was actually on our graph. What was it? It was x was -1/2, so at -1/2, and the y-coordinate was 3, so -1/2, 3. So this is a point that was on both of the graphs. We can actually graph, let's graph the line first. So y equals -2x plus 2, -2x plus 2. So that line looks like this, -2x plus 2, has a y-intercept of 2, goes left 1 up 2, left 1 up 2, left 1 up 2, somewhere up there, and then right 1 down to, I did steps of a half, but I could have done steps of 1, whatever. That was the line that was tangent. So maybe I can make that a red line because it's a tangent line. That was our tangent line. And then once we have our actual parabola, I'll make that blue. Our parabola touched that point exactly. So this point is also on the parabola. And it had this vertex, and it came, and it's mirrored over itself too. So if that point -1/2, 3 is on the parabola, +1/2, 3 is also on the parabola. So it came up like that and touches just there once and then never touches again. It's just that one point of tangency. So again, all of the action for this problem happens at one point. That point is -0.53, but your first goal in solving these problems is, what is that point that you care about? What is that action point? And we first solve for y prime to figure out what was going on. Once we found that action point by taking the derivative, then it's just a lot of plugging into things over and over again. And it's always going to be the same steps. It's always going to be, you start with the tangent, start with the curve, take the derivatives, plug it into the tangent, then plug it into the curve over and over again. So I think I have another problem on the back. No, I don't. That's just it. So you have lots of time to do homework. Questions about this procedure? You see Teflon's forehead, so I assume she's okay. Okay, cool. I know that we don't have enough information yet to maybe make a correct prediction, but go ahead and predict. Your objective, solve problems with lines that are tangent to functions. This type of problem, where are you feeling on a fist of 5 for our objective for today? 3, 3, and 4. Okay, cool. Let's try the homework then.